Hello everyone, and welcome to our calculus notes for section 2.3, the product and quotient rules, and also higher order derivatives. So first we're going to learn what the product rule is and how that can help us find derivatives of the product of two functions. So if we have two functions that are multiplied together here, just like this, f of x times g of x, we can find the derivative using this rule. So look closely, it's the first function, f of x, times the second function's derivative, g prime of x, plus the second function, g of x, times the first function's derivative, f prime of x. Okay, so one way we can remember this, it's going to be the first function times the derivative of the second, plus the second function times the derivative of the first. So 1d2 plus 2d1. So in our example here, we have two functions. The first one here is 3x minus 2x squared, and it's multiplying 5 plus 4x. So if we want to find the derivative here, h prime of x, it's going to be the first function, which is 3x minus 2x squared, times the derivative of the second function. So it's going to be the derivative with respect to x of 5 plus 4x. Okay, so that's the 1d2. And we're going to add it to the second function, so 5 plus 4x, times the derivative of the first function. Okay, so this is the rule spelled out, f of x times g prime of x plus g of x times f prime of x. So now let's go ahead and find the derivatives of our functions here. Our first function just falls down there. So the derivative of 5 plus 4x, we can use the power rule, and so we know that that's just 4. And then the derivative of this one, we use the power rule as well as the sum and difference rule. So the derivative of 3x is 3, and the derivative of negative 2x squared is minus 4x. So again, the 2 times negative 2 is negative 4. And then we decrease the exponent by 1, and we're at 1. From here, all we have to do is distribute and then combine like terms. So this is going to give me 12x minus 8x squared, and then plus, we might use the FOIL method here, so 5 times 3 is 15. 4x, let's see, 5 times negative 4x is negative 20x, and then 4x times 3 is 12x, and then 4x times negative 4x is negative 16x squared. Okay, so we'll combine our like terms. Looks like our highest degree is x squared, so we'll do that first. So negative 8 minus 16 is negative 24x squared. And then here we have 12x minus 20x plus 12x, and that's 4x. And then plus 15. So this would be our derivative right here. Now, in this example, we could have actually multiplied this out first, so actually multiply the two functions together, and then found the derivative of that function. But if we take a look at letter B, we have y equals x times sine x. So I want you to identify that we actually have two functions. So we can see f of x we could let be x, and then g of x we could let be sine x. Okay, so in this case, if we multiply these two functions together, it doesn't help us out. We can't really combine these at all. So we do have to use the product rule here because we have one function times another. It might be helpful to go ahead and just find the derivatives of these right away. So f prime of x is 1, and g prime of x is, well, what was the derivative of sine? It is cosine. Okay, so now that we have all of this information, we can do 1d2 plus 2d1. So our first function is x times the derivative of the second, so that's right here, cosine x, plus our second function, which was g of x, which is sine x, times the derivative of the first, which is just 1. Okay, so in this case, we would just write x cosine x plus sine x. And there is our derivative. Okay, so this first way, again, it shows you that we're taking the derivatives here. The second way you can do it is actually just take the derivatives right away and then apply the rule. All right, let's move on. All right, let's try letter C together. When we look at this, it's 2x cosine x minus 2 sine x. So in this first section right here, we do have two functions. We have 2x and we have cosine x. In this second part, 2 sine x. It's true that we could write this as two functions, but we're going to use the constant multiple rule instead for this part. Okay, so here we will use the product rule on this part. So if we identify our function as being 2x, its derivative is 2, and if we identify the second function as cosine x, its derivative is negative sine x. Okay, so I think we're ready to go here. So y prime. So let's deal with the 2x cosine x. So it's 1d2 plus 2d1. So 1 is our first function, 2x. d2, so the derivative of the second, which is negative sine x. Notice how I write these in parentheses, so we do have multiplication here, not subtraction. And then plus 2d1. So our second function was cosine x. And then times d1, the derivative of the first function, which is just 2. So that dealt with the product rule right here. And now let's deal with the constant multiple rule. So we have minus 2 sine x. And remember, the constant can just be factored out of that. And then the derivative of sine is cosine. Okay, and now we can multiply these together. Here we would just get negative 2x sine x. Here we would get 2 cosine x, and then minus 2 cosine x. So looking at this, we have a plus 2 cosine x and a minus 2 cosine x. So those actually cancel out. And our final answer then is negative 2x sine x. Alright, I want you to try letter D, and I want you to try it two different ways. One way, I want you to use the product rule. Okay, and then a second way, I want you to actually multiply them and then use the power rule. Okay, so go ahead and try these both ways and compare your answers to see if you got the right thing. Go ahead and pause the video and come back when you're done to check your work. Alright, welcome back. So check your work for the product rule here and just make sure that you applied it correctly, and you should have gotten 40x to the fourth. You'll see that multiplying the functions together and then using the power rule is much faster. So what you want to do is when you identify these functions, you just have to make sure, can I multiply them together? And if I can, to make it into one function, then that's great. That's probably going to be easier. If you can't, then you're going to have to use the product rule. Alright, let's move on. Now we're going to move on to the quotient rule. And just like multiplication and division, division is a little more complex. Division with derivatives is also a little bit more complex. But we can find the derivative of the quotient of two functions. So if we have a function f of x divided by another function g of x, the derivative with respect to x is given right here. So it's g of x, or the bottom function, times f prime of x, or the derivative of the top function, minus f of x, the top function, times g prime of x, which is the derivative of the bottom. Then it's all going to be divided by g of x, which is the bottom, squared. Okay, so denominator times derivative of numerator minus the numerator times the derivative of denominator over denominator squared. Or, as Mrs. Dewar likes to say, low-d high minus high-d low over low squared. Okay, so what does this mean? Low, well that's our low function, g of x. D high means the derivative of the high function, so derivative of f. Minus high d low, so the high function, times d low, the derivative of the low function, all over low squared. Now, in this case, does it matter whether you start with low or high first? Well, because we have a subtraction sign, it does matter. So you have to know that it's low first. Low d high minus high d low over low squared. Go ahead and say that to yourself about 5 to 10 times right now. Ready? Begin. Okay, did you say it? I don't know. I couldn't hear you. Anyway, so we do want to memorize this. Well, let's give it a try here. So we have y equals 5x minus 2 over x squared plus 1. What we want to do is find the derivative of our high function and the derivative of the low function. Okay, so let's go ahead and find d high right here. So what's the derivative of 5x minus 2? Well, it's just 5. And let's go ahead and find d low, or the derivative of the denominator. So d low is going to be 2x plus 0, so it's just 2x. Okay, so let's go ahead and apply this here. So low d high, so the low function is x squared plus 1 times derivative of high, which was just 5, minus high d low, so the high function is 5x minus 2 times d low, which was 2x, all over low squared, so x squared plus 1 squared. Alright, so we've applied the rule. From here now, this becomes purely algebra. Okay, so our calculus part is done, and now we just have to simplify this right here. So in the numerator, we're going to distribute the 5 and get 5x squared plus 5. And then this one was going to be, let's see, minus 10. Well, we'll put the minus sign here, and then we'll keep this in parentheses. So 5x times 2x is 10x squared. Negative 2 times 2x is minus 4x. Now, we kind of like this already in this form. So we're not going to actually square our denominators. We're just going to leave it just like this, because this possibly leaves a chance if we forgot we could have factored something out. So go ahead and just leave that just squared as it is. Okay, now we need to distribute the negative right here. So we get negative 10x squared and then plus 4x. Still all over low squared. And now we'll combine like terms. So we get negative 5x squared plus 4x plus 5 over x squared plus 1 squared. And that is our final answer. Okay, so again, it's no more difficult than just finding the derivative of the numerator, the derivative of the denominator, applying the rule low d high minus high d low over low squared, and then performing the algebra to simplify this down. All right, let's take a look at letter B here. So here, we want to find d high. So first off, square root of x, we want to rewrite it with a power, so we can use our power rule. Okay. So d high is going to equal 1/2 x, let's see, 1/2 minus 1 is negative 1/2. And then d low, derivative of x squared plus 1 is 2x. So given this, we want to apply our quotient rule now. So low d high. So low is x squared plus 1. D high is 1/2 x to the negative 1/2. Then it's minus high d low. So high was, we're just going to leave it as x to the 1/2. It's a little easier to work with. Times d low, which is 2x. And this is all over x squared plus 1 squared. Alright, now we go to work with the algebra. So we're going to have to remember how we deal with multiplying exponents and how we add them together. So in the first part, x squared times 1/2 x to the negative 1/2. So that's going to be 1/2 x to the, well, let's see, so 2 minus 1/2 is 1.5, or we can write it as 3/2. Okay, and then 1 times this, so plus 1/2 x to the negative 1/2. And then minus, so x to the 1/2 times 2x, so that's going to be 2x to the, well, so this is a 1, so we want to go 1/2 plus 1, well, that's 1.5, or 3/2. And this is all over x squared plus 1 squared. Now we can combine like terms. So we have 1/2 x to the 3/2 minus 2x to the 3/2. And so that's going to give us negative 3/2 x to the 3/2, and then plus, we still have our 1/2, x to the negative 1/2, and it's going to be all over x squared plus 1 squared. And that is ugly, but it is our final answer. All right, let's move on to our next example. In this case, we want to be careful that we can't simplify this before we use the quotient rule. So we always want to try to simplify first. Okay, so first we want to factor out the constant, so negative 3/7, and we're left with 3x minus 2x squared over x, because we took out the 3 and we took out the 7. Then you can see we can take an x out of both of these, so let's factor out our x. Okay, and then we can cancel it right here. So we're left with negative 3/7 times 3 minus 2x. Now, if we're talking the derivative of this function, here's a case where we have a constant multiple out in front. So remember, we can pull that out in front just like so. And now we can find our derivative. So what's the derivative of 3 minus 2x? Well, it's just negative 2. So this becomes negative 3/7 from our constant multiple, and then times negative 2, which becomes 6/7. So the moral of the story is, just because you have a quotient here doesn't necessarily mean you have to use the quotient rule. You want to see if you can simplify it first, and then we came up with a linear equation, and finding that derivative is a lot easier, finding the slope. So here we have 6/7.